All right, welcome everyone. My name is Mateusz Pusz, and today we are going to make some friends. This is the Back to Basic track, right? So we are going to talk about fundamentals of the C++ language, and we are going to scope mostly on the friend keyword in the language. Regarding me, I am the principal software engineer at EPAM Systems, and also I am a trainer and a consultant for corporations. So I also provided a workshop during last weekend here, and I'll provide also one more after the conference. It's an online workshop starting on Monday. As I'm a trainer, I will provide this class in my typical workshopy style, because it's not really a workshop, because you have just 1 hour, and we actually cannot do some hands-on coding. So lots of coding actually will not happen today, but I will provide some rationale. I will try to facilitate some discussion, try to force you to think, for example, through this quiz that you can scan the code and join. And so this is not just a lecture. I will describe pitfall corner cases and provide recommendations on how to write proper code. All right, so if you want to join the quiz, if you want to have a chance to win a reward, a prize in the end, then please scan the code. And let's maybe start with the first question. I still see people coming, so I will give them a chance to scan the code. So if you want to join the quiz, scan the code, because I'm switching the slide now. Or someone can share the code from the cell phone. All right, so let's start with a simple question in the beginning. This is not a quiz, this is not for points. I just want to provide you some input. Did you actually use friend keyword in your last project? And let's maybe switch to the quiz itself and see how it looks. So, did you use the friend keyword at least once in your project or not? All right, maybe I will give you some more time to actually join it and answer. So whoever didn't have a chance, please answer. There's also still a link in the top here if you didn't join, and I will also provide you QR code for the late joiners to the training. So what we can see, most people didn't use friend. They either don't need it, or they are afraid of it, or they actually ask to not use it. And we are going to talk about this today. Some of you use it, some of you are asking who is a friend. So I hope that everyone here in this room can become our friend after this talk. I will revert this a bit back again for people that join. You can still join the quiz if you didn't so far. And maybe let's describe also the rules of the quiz itself. So right now I'm seeing that people are already there and not coming anymore. So the rules of the quiz are as follows. There will be multiple choice questions, like we had just one before. This one was not scored, but there will be similar questions. The more correct answers you select, the better, the more points you get. However, if you will select an incorrect answer, you get 0 points for entire question. So the hint is to not guess, just mark the correct answer and submit the answer as soon as possible, because faster answers get more points. All right? So those are the rules. All right, so those are questions from now, and you can choose right now one of your favorite emojis while I'm talking for a moment about what we are going to learn today. I would claim that friend is a powerful tool, but like art, it requires skill, understanding, and careful application. We are going to talk about this keyword, and we are going to talk how to avoid overuse of this keyword, how to use it judiciously, and appreciate the nuances of this usage of this keyword. Probably you've heard a lot of statements similar to friend is evil, don't use it. Is it a myth or true? We are going to find out. Common belief is that friend breaks encapsulation and should be avoided. That's why maybe most of you actually claim that they are not using friends here, because you were told or you know that you should not use it for some reasons. Let's challenge some of those assumptions during this talk. I will try to prove and describe that friend is often misunderstood rather than inherently bad. There is a feature called hidden friends, which actually are really, really great and actually improve your code a lot. The real problems come from misuse, not the language feature itself. And in modern C++, you can actually make friend shine in some patterns. All right, so let's start with the first quiz question. What will be the outcome of this program? Where's my cursor? Here. You have actually right now quiz on your cell phones. I hope so. Or not. If not, yeah, then let's wait. Yeah. Sorry. We have some answers, 11, 12, 13 answers. Let's see. There will be compilation error. And I should probably should provide this a bit longer, but wanted to show you that actually the timer works there for you. There will be no text 42 on the screen because you want to print 42 from value, but there is no streaming operator, right? You have to provide streaming operator for this to work, right? So this will be the error you get. And you have to provide so-called customization point to the program you want to compile, right? What's the customization point? Customization point is typically a function that describes how to subscribe your specific type, like this one, to your engine that you want to use. In this case, our engine is a streaming facility provided with the language, right? Everyone knows what we should do here, right? We have provided streaming operator. It's one of many customization points that we use in our programs for our user-defined types. Most generic frameworks like that depend on so-called argument-dependent name lookup to find your customizations. I will not talk about ADL today because I did a few years ago here on Back to Basics track. You can find my talk. And we're going to talk about friends, but friends typically are useful, as you will find out later on, together with ADL for customization points that we are going to learn later on during the talk. So again, this time I provided here the streaming operator. I have a struct with value inside, and I want to print it this way. Again, in the quiz, next question. What will be the outcome of this program? Where is my cursor?
I didn't get it.
There was no question for you? There should be some people answered actually, right? This is the same question that was before. Maybe you didn't actually notice that is the same question that was before. Most of you actually answered this time correctly and didn't fall into a trap that I actually provided on the slide. There's no compilation error. Sorry for that, I was a bit tricky. I just wanted to grab your attention in the beginning. This is struct, right? This is struct, so this member is public, even though it may not look like that one. So there's no compilation error in this case. And actually, I've seen code like this in production about constantly code bases. And this goes through code reviews because it looks like proper code, right? It's just a keyword that is wrong.
Was it class previously?
No, previous was also struct. Yeah, but there was no streaming operator, so that's why it failed. Right? So beware that this may be misleading during code reviews And this still is a public member, not a private one, right? So this prints 42. If I put class here correctly, as actually we should do probably, then we have an error, of course, that gives access to the private member. So let's talk about the class member access control. C++ offers a rich access specifiers to control the visibility of the class members. We have public members that are accessible to everyone. We have protected members that are accessible to the current class and its children. And we also have private members that are only accessible to the current class and no one else can see it. Right? And we have two different keywords that we already faced here during this talk. We have class that provides private access to our members, but not only to members, but also during inheritance, we choose private inheritance. In case of struct, we have both public access to members and public inheritance by default. Right? So I don't have to put public here. This is still public interface. And in base, also I have public access to base through such an inheritance. We can make our code to compile with this class that was failing a minute ago with providing a getter and just provide a getter here. However, getters often are not a good solution. Providing getters and setters for every member of your class typically is considered as a bad design. All right? Typically, classes are encapsulated. They have some private members to provide some wider logic, or also to allow you for easier refactoring of your code without affecting customers. If you will provide a getter for every single member in your class, then you cannot refactor this, because this member has to be provided. Even worse, if you are providing a getter that actually provides this integer by reference, then actually you have to have a storage of this type inside. Because with the value getter, you could probably recalculate something based on the members. Right? So adding a getter may work, but it often breaks encapsulation of the classes and should not be used for such cases. If it's used for other cases, if it's useful for other things, it actually makes sense, then you can add a getter, right? But we don't want to have getter for many different types. Like, for example, we should not have a getter for I don't know, string internals and so on, returning references exactly to those things inside. All right, next question. This time, we'll have class with private value and operator plus that takes another class of the same type and wants to add the values inside. And they want to add it this way. They have value 42, and they want to add 1 and 1 plus I. What is the outcome of this program? Again, next question in the quiz. Just let me switch the quiz. All right, let's see the answers. Come on. Good. Number 2 does not compile. Most of you are correct. This code will not print 4343. And number 1 will compile. Number 2 will be an issue. Number 2 will be an issue because it requires the conversion of the first parameter, first argument of this expression, and it will not convert to my int because there's no operator that actually works with that. Only the right-hand side parameter will have conversion. So this conversion will work to my int thanks to this converting non-explicit constructor. But the left-hand side, there will be no. Compiler will just tell us that there is no operator plus that works on an int and my int. So this is not a correct approach to provide operator plus. But this operator plus, because it's a member, has access to our private value. The correct way to do it is to make operator plus a non-member function. And most of the binary operators, if not all, should be implemented as non-member functions. Right? Such an approach allows the implicit conversion for both arguments, left-hand side and right-hand side of our expression. So I'm providing here the operator plus being non-member function, and as I don't know what a friend is yet, I provided this getter that I said is not the best idea. And it works. In both cases, we see the outcome. It's 43, 43, and it works nice. I could also, assuming that this function is provided, use operator plus equals, which typically is public, and then I can get rid of the problems with the private member inside. But to not have a getter, we have to talk about friends. Why does the friend exist? Access control is the key principle in C++. We want to make sure that we encapsulate things properly, that we hide some things from the user, that the user cannot use it, but we are hiding this from the user, so not only that it cannot use it, the intent is that it cannot break it, and also cannot depend on that, right? Hiram's law, that user will always depend on everything that you actually provide, even if it's not your intent. Because you want to be able to refactor this later on, possibly. Change the implementation details without affecting the user. Right? Some non-member functions need the access to private members and cannot be implemented as member functions, like operator plus, for example, or streaming operator that we've seen before. Those cannot be implemented as member functions which will have access to private members. So you have to solve it somehow, and we have friend for that. Right? So I declare two functions that we already have seen, streaming operator and operator plus, as friends to grant the access to our private members to those two functions. And I then define those functions outside, and I now have nice access to our internal implementation details. With that, I can add stuff, I can print stuff, everything works. So what does friend do? Friend grants a function or class access to private protected members of another class. Traditionally, friend is being used like we just did before. So when we need access to the private members, and this is most known use case for this keyword, but not the only one, as you'll learn later. Another quiz question. I provided here declaration of friends functions as public or as private. Is there any difference? Because my students often ask me, should I provide this public or private? Does the private mean that actually those are visible to the customer if they're in the private section? Is there any difference? Let's try to answer this in the quiz. Most of you are correct. There's no difference. It's exactly the same. And I love this answer. It depends. In C++, it always depends, right? That's why I put it here. But no, this is not the correct answer this time. Yes, this is exactly the same. No matter what I do, I have exactly the same observable behavior. This code will just work. Access specifiers have no effect of meaning of a friend declaration inside of a class. You can put it in public, protected, private, and this will be exposed as a friend function to everyone. Well, to everyone, to the function that actually is specified, but everyone will be able to see that. All right, so what can be our friend? Can be a function, either non-member or member, can be a class, can be a template. Non-member function template, member function template, class template. For example, in this case, we have a bank account example. It has a balance. Each account has a balance, and we have transfer funds function that wants to come basically to transfer some money from one account to another. Right? I am even having here the getter called balance. But this is const function. It does not allow me to mutate the class for this member. Exposing a member that is non-const and returns a reference, well, it probably not be the best idea because everyone will be able to get our balance and change it with no control. Right? So that's why this getter will not work here, and I have to make this function a friend. So this friend has access to our private members and change them in a safe way. Well, this is slideware, right? But it should work like a transaction, of course, if something goes sideways. If I want to complicate my design a bit and make a transaction a class that, for example, has a run function that has check balance and then transfer is a virtual function here, then I have to specify this function in this way as a friend. And this is the proper inheritance, proper polymorphic approach, where you have public member exposed to the user and private virtual functions as an implementation detail, not exposed in public interfaces. If you can achieve this, it's a better design than making those functions public. And now, another quiz question. Is it okay, right? Does this code work as expected? Does this code compile as expected? What might be a problem if there is any? Let's see. Is it okay or not? Oh, actually, it is not okay, as some of you answered. Unfortunately, this code doesn't work. This code doesn't work because it turns out that even though I said this is a friend and this function can access it, but I cannot make this function friend because it's a private function of this class. So this actually requires us to put this declaration that we have here, the bank account, to put it and define as a friend of our class. So this one now can see this private function and make it a friend. A bit non-intuitive, but this is how it works, right? So you have to have two friends in this case to make this function see our internal details. And now again, this is another quick question. Is this code okay already, or it still have some issues? Let's try to find out and think about it for a while. Four of you say that that's okay. Most of you that it's okay. Unfortunately, it's not. It's not because this one is a friend declaration, but not a class declaration. That's why if you want to make this here a friend, you'll have an error saying bank account does not name a type in the balance here, this one. So even though you specify this as a friend, this type is not known. So actually, friend class declaration does not declare a class in such a way. Explicit class declaration is still needed, so you have to put from for declaration here, then friend declaration, then transfer as a virtual function, and then friend this function so it can access our private members and change the balance. This starts to be a bit complex, right? But but this is what has to be done in case you want to connect two classes through friendship. If you want to make it a template, so transfer funds right now is a template function template, and you want to declare this as a friend, you do it this way, and it just works. However, when you want to make this representation type also a representation type of this bank account, so I move this type name from the function actually to the type here. So bank account is also has the same representation. So we have class template and a function template with rep. You have to actually first forward declare bank account, so this type is known. Then forward declare this function, so compiler knows this is a template, and then you can implement this function below. So in this case, we have to provide for declaration for the class template, and then function template declaration, and then only we can say this function declaration for specific type rep will be your friend, because we are using exactly this type rep here, and specifying this rep here as well. Typically, if you have bank account, like, actually I don't have it here, but if you're writing like copy constructor or other stuff, you don't have to repeat rep in the same class template, right? So you can remove this this rep from here, and also provide here empty brackets. It's exactly the same, because this rep is actually what you are using in this class template. Some more examples. If you have a class template and you want to say that any B is your friend, then you specify it this way. If you want to say this should be B of the same T, you provide it this way. If you want to say only B of int is your friend, then you do it this way, and all of those work. Assuming that B is known before, right? Because you have to declare this as a class template before. Let's talk about encapsulation. I claim that encapsulation is an art of bundling data and behavior associated with a single responsibility behind a clean interface, which is basically hidden from the user, right? It conceals implementation details, secures class invariants, and enable effortless refactoring. All of this is encapsulation, not just a part of it. And now I have a question to you. What is your feeling? Can adding a member function, not friend, just a member function, decrease encapsulation? So putting members functions decrease, increase, or doesn't change encapsulation? Let's try out. Let's find out what you think in the quiz. It didn't move? Still friend classes? Okay, sorry. All right, now. What do you think? Yes, adding a member function can decrease encapsulation of a type. There was a really nice article by Scott Myers, who said that if you are writing a function that can be implemented as either member or non-member, non-friend, non-member, you should prefer to implement it as a non-member function. That decision increases class encapsulation. When you think encapsulation, you should think non-member functions. Non-member functions don't break our ability to refactor class. If you have 100 overloads or 100 functions as member functions inside the class, and you want to change members, then typically you have to refactor entire 100 functions. If you have non-member functions that depend on the public interface of a class, then refactoring is easier. This is why basically encapsulation is broken or decreased with every added new member function. And there are perfect examples of such broken types in the standard library. For example, this one. This is not my favorite one. And guess what? With every single C++ release, we are adding new functions here. This mostly connected to the fact that it's already bad, so it will not be much worse. And besides, people love to type dot and see the list of all of the functions they can call. Right? But this actually makes it harder. Now imagine, I want to change internals of basic string. I have to update all of those functions. I actually want to propose in-place string for the next version of the standard, and I have to provide all of those functions as well, because it has to be a replacement for string. So this is implementation problem for library developers. It's a specification problem for ISO members. I have to write a paper with so huge things. And it's also a maintenance issue, because if in the future we will be able, or we want to add a new member to any of those, we have to remember to update all of them, because users will not be able to switch from one to another easily. So think about it, think how you design your classes, and try to not repeat those mistakes. Right? Non-member functions are preferred in many cases. Question, but you may come to the microphone. Mm-hmm.
I understand how adding these member functions can kind of break encapsulation and make future changes harder. But if every one of those is replaced with an external function using friend or something, you can break, you can't change those either because existing code depends on those, right?
Sure, yeah. Okay. It is a valid comment, but I didn't say anything about friends yet, right?
Okay.
Right? Typically in string, you would probably need something like 10 functions that provide you access to the most important properties of a string. Mostly it's storage. And then functions like first of and so on, find first of and other functions can be implemented in terms of this public interface. They don't have to be in the string itself, right? So expose the minimal public interface that allows you to keep encapsulation nice and refactor in the future, and allows you to implement all of those operations and implement them as non-member functions. Typically also, the great thing is to make them a template, so then one generic implementation will serve all of string-like abstractions, and you don't have to provide more, right? So this makes you lazy. And I often say during my workshops that the best C++ developers are developers that are lazy. Don't type too much code, because if you type code, typically you may introduce errors, right? That's easy. And we want to save time and not have problems with our code. Right, so 140 member functions plus 25 special member functions in string, and it grows. So, do friends violate encapsulation? A C++ FAQ says, a friend function in the class declaration doesn't violate encapsulation any more than a public member function violates encapsulation. Both have exactly the same outcome, right? So, if you hear from your friends that they say, don't do friends for functions because they break encapsulation, and those the same friends are adding members to your class, ask them, what's the difference? Because there's none. All right, properties of friendship for class templates or classes. Friendship is not inherited. If I specify that a base class here is a friend of X, then base class can access X, but the derived class of base cannot access X. Right? We'll get an error. Tight coupling between two types, like X and base, is fine when they are created and maintained together. There is, let's say, nothing wrong with them. Sometimes you cannot implement them as one, because, for example, they may have different lifetimes, but they are tightly bound together, and you can introduce some such coupling. However, exposing that to customers will be a maintenance nightmare and prevent any changes in the original type. Friendship is not transitive. If we have class X again, that this time will specify Y as a friend, and Y has access to our X, and also specify that Z is its friend, and Z has access to Y because it's a friend of Y, Z will not have access to X, even though it's a friend of X here, right? So here we'll not be able to get through Y to X, even though Y has access to X. friendship is not mutual here. If X has a friend Y, Y not necessarily is a friend of X. Again, quoting C++ FAQ. Just because I grant you friendship access to me, does it automatically grant your kids access to me? Does it automatically grant your friends access to me? It doesn't automatically grant me access to you. That's a really nice quote to understand how friendship between classes work. If you want to take one thing from this training or this talk only, remember about this. Friend is not a solution for unit testing. Please don't. I've seen it so many times as a consultant. Right? We have some official framework, production code, implementation details, more implementation details, and then we specify friend class framework test to provide unit tests for those things. Just don't. This breaks encapsulation, increases coupling between tests and implementation. Non-breaking changes to private members require modifying tests. This is a bad design, broken design. Actually, it leads to testing internal details, which you should not. You should test public interfaces and how they behave, not the internal details. If you are doing this, it means that probably your type is broken, that this started to be some huge monolith with thousands of responsibilities, like 20 members, 100 functions, and you want to test them in isolation. That's not how you should write your code. Apply single responsibility principle. Decompose the monster that you created into smaller classes where each has its own responsibility and test it separately through public interfaces. Use dependency injection if needed. Mock interfaces if needed. And use public getters only when necessary, right? So again, you should not use getters for things just to make streaming operator work, or not provide getters only for unit testing, because I've seen this as well, right? We don't need the getter anywhere in the production code, but we need it to provide some access to the test so they can test it. No, this is also wrong. And please, 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 don't do it. I've seen it so many times as well. I went to one team, I told them to not do it. And they say, okay, we'll remove it. Next day I'm coming, then Berk, and they have this. This is cheating. This is cheating, don't do it. All right? When friends are not needed. If you have some class or class template like this one with some internal data and you want to implement an iterator that should iterate through this buffer, then this iterator, being a nested class of storage, has private access to this storage already. Iterator does not have to be a friend in this case. As it is a nested class has access to private members of its parent class. So this is, friend in this case is not needed. Some time ago, I actually approached a really nice article by Arne Mertz. He said that friendship is the strongest coupling we can express in C++, even stronger than inheritance. So you'd better be careful and avoid if possible. Friendship is, as we already discussed and established, is often seen as an indicator of a poor design, mostly caused by the lack of friendship granularity. When you make some class or some entity a friend, it has access to everything in your class. And especially in case of those monoliths that we just mentioned, then it may not be desired. Right? It can mess with any single member in our class, not only the one that it needs access to, but only to all of those that it doesn't need access to. If you have those monoliths and the refactoring is too expensive, you can use one of the idioms that I'm going to show you. So this is a huge class, let's say, and that has some session factory, and it requires to provide a friendship for the session factory, so it can call this private constructor here. Because it's a private one, only factory should be able to create our session. But we also have some other members here, like generate random token, or even secret token here stored here, right? If you make this class a friend, it has access to all of it, right? So I can create a session, that's fine, but I can also hack and override the secret token, which probably is not desired. What you can do? You can use passkey idiom. Passkey idiom provides additional class here that is a private class, so no one outside can actually see it or use it, right? And then you specify that session factor is a friend of this class. It has also private constructor, so no one can construct it, and also copy constructor here. And then here, you specify this constructor key as the last parameter of your function you want to basically allow to use, in this case, our constructor. In this case, the constructor is public, notice. It is public, it's not private anymore. And it is fine, because only the class that has access to this through friendship can create this last parameter of the function. Everyone sees this function, but no one can call it besides this one. Right? So what I'm doing here, this is the session factory that is a friend, has access, so it can create the instance of this class even with single braces here. And with this, you can provide more granular access to specific functions in your interface. Important things to notice about this pattern is that before C++20, you actually have to provide implementation here. This makes this class non-trivial, which I hate about it, but, well, until C++20, aggregates were broken. And you could cheat, you could provide actually this aggregate initialization, empty braces, and even though the constructor is claimed to be private, it will just work. We fixed this in C++20, so it will not work anymore, so default is fine. But before it was a problem. Also, this one is needed because you could create such a hack. You could say, I'm not creating an instance of this object, I'm just taking a pointer to it, which is null pointer, and then do the reference of it. Of course, it's UB, but it will work on most of the compilers and give you access to this constructor. Because you are not using this pointer anywhere, so it will not crash anywhere. So that's why actually this has to be also provided, and then this is not possible. So with this, you are fine. Another possibility, another idiom to use, is so-called factory attorney. What we have here, we provided all of the interface here as private. Also, this constructor is private again, with no additional parameters. But we specified special additional class that provided session factory, again, as our friend. And we have static make function. Only session factory can call this make function, which calls our private constructor. Right? So you have here session factory, factory attorney, and we call make. We are the only ones that can call this function make, and only we have access to this private constructor. Right? So those are the possibilities to actually expose only a part of your interface to your friends. But as I said in the beginning, this is probably a bad design because this means that your class is doing too much. And that's why you have to protect through those idioms. It's better to decompose it and then provide access to only specific parts of it. It will be much better. All right, let's recap. I started with this slide and show you this error, right? Because there was no stemming operator. I lied. This is not entirely true, because this error doesn't look like this one. This error looks like this one, right? I just showed you the first line of this error, and there is 121 more. If you think that's a lot, then it's not that bad because it's Clang. You didn't see the GCC output yet. This is GCC output. Notice smaller font. There is 300 lines more. And there is a note here. There are 52 candidates to call your function. All right? What happens here? I included only IO stream. If I include more headers files, probably this would be even longer. This is a side effect of our customization points. If you have a popular customization point, like stemming operator, operator equals, less than, there are plenty of overloads of this function with the same name, just different arguments. Name lookup has to find all of them, then overload resolution has to deal with all of them, which actually is not fine in terms of those error messages. Name lookup and overload resolutions are often the most expressive parts of your compile time performance. Let's see something else. Besides having my int that you've seen before, I also have my float. And I forgot to add here operator plus. When I call it, I get this error. Invalid operates because there's missing function, but it also says no conversion from my float to my int. Because it sees the other overload that you provided, which was a friend of my int. Right? So it says I checked this overload, but this one was working on ints, not on floats, and I cannot convert float to int. This is a correct error message because this code is accessible to this expression, and the compiler says, well, I analyzed this one, but this is why it doesn't work. Those errors are not bad. There's actually really good justification for those errors to look like that and be that long. You expose all of those functions. I analyze all of those functions. None of them work. I tell you why. Right? We complain about error messages being long, but, well, this is how we structure our code. So I have Paul. This is not for points. But let's see. Have you ever blamed templates for slow compile times of your projects? I didn't move that. That's okay. Wow.
I blame Unreal.
All right, so most of you didn't blame templates. That's actually surprising because plenty of people blame templates for compile times. And some of you are really lucky to have really fast build times. That's not your problem then. All right, so let's find a solution for that, for those long compile time error messages. As I told you, the name lookup and overload solution typically is the slowest thing you do through compile time, not template instantiations. We can actually fix it, and we can fix it with such an idiom. I refactored my int to not have declaration of functions and then functions defined behind the class. I now provide the definition inside. So they are declared and defined in the same class. Where's my cursor here, right? Declaration, definition in the same class. And it works. There's no need to declare anything, as everything is defined in a class template, so you have to type less. Lazy developer C++, good, right? Every time you have to write some additional code, think if you can write less. Typically, you will have a better code. So also for function templates that you've seen, you have to first provide declaration for a class template, then function template, then actually specify it's a friend, and then provide definition. I wrote everything twice at least. There was plenty. With this, it will also work. You will just specify it here, and it will work nicely as a function template. Right? Notice that those two, right now, are not much different from member functions. Right? They are nearly the same typing. I just have to add friend additional characters to type, but I don't have to provide those expensive declarations. I don't have to search for entire file to find definition of this because it's defined in different place than my member functions in the class. Here, everything is the same next to member functions with no much overhead, which is much better as well. And now let's try again. The same broken myFloat class only says I cannot find anything for this function. Notice that my int overload is not visible anymore. It doesn't propose me my int, which is specified like that. There is an my int operator plus, but it does not propose it anymore. My error message got shorter. My compile times improved. Because this is the so-called hidden thread. One interesting property of those friends, I'm adding here another function called ABS. I provided this in an old style with declaration and definition outside, and I call it ABS, it works. I did it the same with hidden friends, and it works. Now I want to call it with unqualified lookup, for example, through the namespace name. Left column works, right doesn't. That's why actually we call them hidden friends. Their definitions or their access is hidden. They are actually not possible to be called through dot because they are non-member functions. So they are not possible to be called with member syntax function. But also they cannot be called with non-member syntax with qualified lookup. They can be only found through ADL. So a hidden friend function is a function that has a friend keyword, basically a definition declaration in the class, in this line, and there's no other declaration besides the class, outside of the class. Such a function can be only found through ADL. But I also said that most of the customization points actually look for the customization through ADL. So this is a perfect match, right? Customization points are looked for by ADL, this is exposed by ADL, so they can find each other nicely. And they will not make those overloads huge when you're actually doing name lookup. If we had hidden friends for all our classes done properly with hidden friends in the standard library, then you will not see those monstrous error messages with 120 overloads. We just didn't at this point because we didn't know about this property or didn't care about this property that much. Now we know better, probably we would design it differently, but we didn't then, and we cannot change right now. Right, so recommendation is to prefer hidden friends rather than global non-member functions to overload operators or implement common customization points with common names, right? Swap, maybe ABS, maybe plus, right? All of the operators. Do it even when access to the private members is not needed. If you can implement this as a non-member function because you have access to public members, getters, other stuff, you can, but your compile times and error messages will be worse. Doing this as a friend, even though you don't need private access, is better. You will find out that your compile times will improve and error messages will be nicer. To summarize, friend grants a function or class access to private and protected members of another class. It introduces strong coupling between two otherwise independent entities, like classes. But it is fine as long as those are really connected to each other and cannot be merged for some reasons, for example, different lifetimes. Hidden friend function does not break encapsulation any more than the member function do. Right? So there's no reason to be afraid of them. Friend in C++ is not mutual, transitive, inherited. Use friend when external functions need special access. Right? Functions that can or shouldn't be implemented as member functions, like streaming operator, operator plus, those have to be implemented as non-member functions. So, and need typically access to private members, then you provide them as friend. Also, use hidden friends to improve your compilation and clarity of the error messages, even if you don't need private access. And use friend for two classes that are tightly coupled, but can be merged together. As I said, for example, they have different lifetime or different entity numbers, right? For example, there may be plenty of entities, plenty of iterators for a vector. You don't want to have this feature merged into the vector interface. Avoid friends when public interface suffice, with the exception, of course, of the hidden friends. Don't use friends for unit testing, please. Right? Also, avoid friends when giving access to all implementation details is not desired. Try those passkey idioms, attorney client idioms. Maybe this will help. Or use better alternatives, dependency injection, SRP, and other stuff. So to summarize, friend is a powerful tool, but like art is requires some skills, understanding what it means, what it does, how to use it, and careful application. Avoid overuse, use it judiciously, and appreciate its nuances. Thank you. That's it for my talk. But before we come to questions, I also would like to announce that I will provide an online workshop after the conference, starting on Monday, 3-day course. And actually, for the winner of our quiz, I'm offering 30% discount for this course. And now let's see who is the winner. Doug, congratulations. Where is Doug? Here. I hope you are interested in attending the class. There are also different things that we are going to discuss. Come to me after that. We'll find it out how to make it work if you're interested. 50% discount for the post-conference class. I hope you are still not registered as my student. so it will actually allow you to access this with 50% discount. All right, time for questions. Thank you. No questions? Everything clear? All right. If there are no questions, then thank you very much for coming. I am here until Friday, so you can find me easily. We can talk about friends, other C++ things, trainings, ISO, whatever you are interested in. Thank you very much, and have a nice time here.